day everyone, I am Degadet Jasper S. Eras and we are the group 4 and these are my fellow members. First is Decadet Adrian Johnson, Decadet Christian Hans Idus, Decadet Kimbrel Reyes, and lastly Ryan, Decadet Ryan Indrina. So first is course Intake 101, period midterm, week 1 and season 1. So the topic is compass corrections. This is our learning outcomes. So apply compass correction to determine true course and true bearing. And our deviation is ship specific error due to onboard magnetic influence. Under the magnetic influence is magnetic items to which magnet are attached whilst carrying DC electrical current. And second is reduce effect as much as possible. So keep compass away from influence and twist nearby DC wire pairs. And third is usually can't eliminate them all. So they have so there are the effect of compass error. So as you can see, error due to 0.15 degree west variation and additional error due to 0.05 degree west deviation. And in the left side you can see the desired true heading, and also the compass heading must be adjusted to 0.20 or 0.20 degree to compensate. And measure deviation yourself by using deviation table or curve. We can obtain the deviation value of a specific compass course. So first you have to know how to do some compass calculation.
So good day, I'm the Cadet Kimbrel Rios. So let's continue with the compensation or the compensating of compass. So compensating a compass consists in adjusting the position of the two magnets in order to affect the horizontal component of the card by modifying the north, south, and east-west deviation. So in compensation, we have the deviation of n greater than 10 degrees and the special magnets or the compensators installed in the compass to reduce error. And most compasses come with instructions, and it can still have a significant deviation error after the compass compensation. So how to compensate a compass? So in compensating a compass, first we have to use a second compass as the reference. So a hand-bearing compass is often the most convenient, provided it is interference-free. So the north-south screw or the compensators correct the north-south heading, and the east-west screw correct the east-west heading. So in compensating, first we have to run the boat along the northerly course selected as per our hand-bearing compass and adjust our steering compass by turning the north and south screw either way so that the steering compass also point north. So second, repeat the procedure running the ship or the boat easterly, and next run the boat southerly, and this time reduce the deviation by half, and run the boat westerly and reduce the deviation by half. So in compensating a compass, we have to always take note that upon completing the compensation procedure, it is essential to draw a new deviation table. So next is the compass correction. In compass correction, we have the formula which we can use in the correction of compass. So the TVMDC or the CDMVT. So the T stands for true heading and the V stands for variation on chart, and the M stands for the magnetic heading, and the D stands for deviation, and the C stands for compass course. So if we use this formula downward, our west will become positive and our east will become negative. But if we use this one upward, our east will become positive and our west will become negative. So in this example, our true heading is 0 degrees and our variation on chart is 15 degrees west. So to get the magnetic heading, so we have to use the addition since our variation on chart is on west. So 0 degrees plus 15 degrees equals to 15 degrees. And to get the compass course, since we have a deviation of 005 degrees west, we have to use again the addition. So 15 degrees plus 005 degrees west equals to 20 degrees. So if we use this formula upward, our west will become negative and our east will become positive. So to get the magnetic heading, since we have our division of west, so we have to subtract this one. So 20 degrees subtracted by 005 degrees equals to 15 degrees. And to get the true heading, since we have our variation of 15 degree west, we have to subtract again. So 15 degrees minus 15 degrees equals to 0 degrees true. So next is the worldwide variation. So it is a isogonic chart. So it illustrates magnetic variation in 1995. And this figure, it is a magnetic inclination model for 1995.0. So in this photo, we can identify the degrees of declination and the S declination is positive. So let's proceed to the swinging ship. So swinging ship is a process of measuring residual deviation error after compensation. It usually determined in 15 degrees to 30 degrees heading increments, and it recorded in form of deviation table. And the compass adjuster can provide service or we can do it ourselves. So in measuring deviation, so for each 15 degrees to 30 degrees, we have to first know exactly what direction of our boat is pointed. And next, compare with compass reading and then compute the deviation. So the key to puzzle is knowing exactly what direction of our ship is headed. And there are several ways in knowing our heading. So let's have Kadit Johnson to continue the discussion.
Curious. So good day, classmate. My name is Cadet Adrian Johnson to continue the reporting. Measure example way to know your heading. In calm water with a mineral current, remain in vicinity of atom, record both and compass heading and relative bearings every 15 degrees to 30 degrees. Commute deviation for each heading. So next, measuring relative bearings. Mounted parallel to vessel keel with an all-around view. 0 degrees aligned with the keel. Align target in sight. Read relative bearings on the scale. So next, electronics steering compass. Furniture automated. Deviations elimination. So as you can see the pictures. Next, local magnetic disturbance. Compass still seems wrong. In some location, there are local magnetic disturbance that can be affect your compass, often not on chart. So the next reporter, Ryan.
Shipboard compasses. The gyro compass has three axes: the spin axis, torque axis, and precision axis. As centrifugal force of the Earth's rotation, tangential velocity acts upon the gyro. The torque and precession axis will react and accept the spin axis oriented to a terrestrial meridian. The gyro compass. The gyro compass has several advantages over the magnetic compass. It seeks through an or geographic meridian instead of magnetic meridian. It can be used near the Earth's magnetic poles, where the magnetic compass is useless. It is not affected by surrounding material. Its signal can be fed into inertial navigation system, automatic steering system, and power control system. Being complicated electronic instrument, the gyro compass has some disadvantages. It requires a constant source of electrical power and is sensitive to power fluctuations. It requires periodic maintenance by qualified techniques. Method of determining gyro compass error. Although the gyro compass is very accurate instrument and normally has a very small error associated with its readings, less than 1.0 to 2.0, the navigator is required to determine gyro error at least once a day. Gyro compass error, like magnetic error, is measured in degrees east or west. If gyro compass bearing is higher than the actual bearing, the error is west.
There are other methods in determining gyro compass error that was discussed by the other members. So this is the last one. If the gyro compass bearing is lower than the actual bearing, the error is east. So our reference is from the file that was given then. That's all for our group report. Thank you.